Hello, today we will be moving more further into networking. The first topic which we are going to study today is methods of signal transmission. There are three methods of transmitting signal in the networks. Okay, the first one is electrical signals, the second one is optical signal, and the third one is wireless signal. Or we can say these all are the mediums through which we can transmit signals. From electrical way, there are two devices, that is twisted pair cables and coaxial cables we use, and also Ethernet. We use these devices to transmit our signal through electrical medium. Okay, and for optical signals we use fiber optic cables, and for wireless signals we use infrared, microwave, and radio wave as a medium. Here it is twisted pair cables. It is widely used in local area network, that is, it is used for short range. It consists of pairs of insulated copper wires twisted together to reduce electromagnetic interference. Okay, that it can transmit or receive data. Both it can both transmit and receive data. As the signal pass through electrical electrical medium in the form of impulse, voltage impulse. So it can get uh, it can be lost in quality as per long distances. Okay, so it is not used for wide ranges. Okay, here are the different categories of twisted pair, that is category 3, category 5 or 5. These are all on the basis of um, how fast these cables can deliver data. Okay, now the next is coaxial cables. In this, there is a conductor in the center of this cable, and it is which is insulated, and after that there is a metallic shield, and there is also another insulating layer over it. It was the structure of coaxial cable. It is mostly used for cables for television, broadband internet. Okay, it is fiber optics cable. This cable uses light to transmit data. Yes, light is used to travel from one place to another in this cable. Okay, this works on the principle of law of refraction. It is used in transmitting data for long range. For example, it can transmit data up to hundreds of kilometers. It is much more efficient than the copper cables which we studied in last two slides. And we must have heard that the entire globe is connected with internet through the optical fibers which are being passing which fiber optic cables which are being passing under the sea and connecting several countries and coastlines. These all are because it can carry data and signal up to hundreds of kilometers. Here we will be discussing about different network devices. Network devices are generally classified into two categories. The first one is network access devices, and the second one is network infrastructure devices. In this slide, we are going to know about network access devices. Devices provide a connection between user's device and a network. Let's see a few of these devices. The first one is NIC, that is Network Interface Cards. NIC is a card that allows a computer to connect to a network. It has a unique identifier address called MAC address. Yes, MAC address. The device is modems. A modem converts digital data from a computer into a format that can travel through physical media such as coaxial cables, phone lines, and many more things which we learned in last slides. Devices wireless access point, that is WAPs. This devices allows wireless devices to connect to a wide network. That's it. It interacts as a bridge between wired and wireless devices. Let's see about network infrastructure devices. These devices are responsible for the flow of data within a network. Yes, we got the difference between the both categories of devices. First one was providing a connection between user's device and the network, where the second one is um, managing a flow of data in a network. Let's see about all the devices one by one. A tree is a device that connects to or more networks and tags data packets between them. It determines the best path for data to travel based on the IP addresses. Next device is switches. A switch is a device that connects a device to a network and forwards the data packets to an appropriate device based on their MAC addresses. The next device is firewalls. We must have heard about firewalls so somewhere in terms of security, data security. Yes, a firewall is a security device that monitors incoming and outgoing network traffic and allows or delete or block restrict data packets based on a set of security rules. Basically, it protects our network from any unauthorized access. And the next device is hubs. Hub is a kind of junction where, or we can say that a hub forward data packets to all connected devices. Okay. Now the next device is gateways. Gateways connect different networks and transfer protocols. Okay, whatever. Next, next device is load balancers. A load balancer is a device that distributes workloads across multiple servers. Yes, it helps to improve the performance and reliability of a network by preventing any one server from becoming overloaded. Proxy server is kind of a middleman between our devices and the server. The next is the network attached to storage. It is dedicated to file storage devices that provide data access to a heterogeneous group of clients. Okay, whatever. That's it for all about network devices. There are a few methods of sending traffic on paths that everyone can access at the same time, or we can say that sending different types of signal with a same channel. Okay, and at the same time, everyone can access that. We will be discussing few of the methods like FDM, that is frequency domain multiplexing, and time domain multiplexing. Okay, here it is a basic diagram of frequency division multiplexing. Okay, I think I have go to the diagram of electronics department of frequency division multiplexing. Okay, let's understand it. FDM by have. Let's assume these are the in left side. These are three devices which are uh, emitting emitting signals at different frequency. Okay, let the frequency of the first device is FC1, the second device is FC2, and third device is FC3. This all are nothing but the frequency emitted by I think I'm getting wrong. These are the devices is emitting signal at this frequency. Okay, and ignore that M1 of T and FC. That is um, that is modulation. That another concept. By now, left side we understand just a single thing that three devices are emitting their signals on different frequencies. that is F1, F2, and F3. Okay. After that, there is a mixer which mixes all the frequencies and pass through a single channel, which was the concept how we can transfer different uh, signal in a single channel. Okay. On the other hand, on the other right hand side, we can see here there is a band pass filter present here, which allows a desired frequency to pass through them. Okay. Um, Due to this band pass filter, this desired frequency of F1, F2, F3 can be accepted in what? Okay. Here we got the signal. Okay. Don't go to the complex structure. The main two things which are playing a role in this simple, that is the multiplier and the mixer and bandpass filter. Mixer is mixing all the signals which are coming through different frequencies, and bandpass filter is selecting frequency, selecting signal by its frequency. Third is all about uh, time division multiplexing, that is TDM. In this multiplexing, the time is divided into different slots. Each signal or data stream gets its own time slot, allowing the multiple streams to share the same transmission medium without interfering with each other. It working is like multiple data streams are combined into a single signal. This is done by allowing them a unique time slot. Okay, the signal is transmitted over single channel. Okay, at the receiving end, the signal is separated back into the original data streams based on their assigned time slot. Okay, yes, in this method, I think it is outdated method. I am not sure about that. In this method, we can, in a different in a certain time slot, only a signal, only one source can transmit their signal. Okay. Now let's know about Ethernet. What is Ethernet? Ethernet is a widely used networking technology that connects devices in a local area network or wide area network. It enables devices such as computers, printers, and servers to communicate with each other by using a set of protocols and hardware standards. Okay. Ethernet transmits data using packets or frames, which contains information such as source, destination address, data, or yes, okay. We will be studying about the Ethernet frames further. There is a concept in Ethernet, that is slow Ethernet. Ethernet having transmission of around 10 Mbps, those are called slow Ethernet. The Ethernet having doing transmission receiving of 100 Mbps, those are called fast Ethernets. And the Ethernets which are doing transmission receiving up to 1 Gbps, those are gigabit Ethernets. Networking devices like switches and routers are crucial components of Ethernet networks. Switches connect multiple devices with the same network, while routers connect different networks and manage traffic between them. Now let's know more about Ethernet frame structure or data packet. Okay. And Ethernet frame is like a package of data sent over an Ethernet network. Here in the slide, you can see different components present in an Ethernet frame. Here, the first component is preamble. It is of 7 bytes and used to synchronize the communication timing between devices. It also helps the receiving device to recognize that to recognize uh, in the starting point of frame. Okay. After preamble, there is SFD, which is start frame delimiter. It is switched between preamble and destination MAC. With uh, the value of SFD is always fixed, that is 10101011. Sometimes it get it considered in the preamble along, or we can say along with the preamble. Now the next component is destination MAC. It is a 6 byte, that is 42-bit field that specifies the MAC address of the receiving device. And the next is source MAC. Similarly, it contains the MAC address of the source device or source. The fourth component is length or type. Actually, there are two types of Ethernet frames. First one is Ethernet 2, and the second one is IEEE 802.3. In Ethernet 2, there is the length, and in IEEE 802.3 Ethernet, there is a type. So in Ethernet 2, there is type, and in IEEE 80.3, no, 802.3, there is length. After that, there is a component of data, where the actual data has been embedded. After that, the component is CRC. It is nothing but the kind of error detecting code used to find accidental change in raw data. It is derived by some few calculation which is being done inside the data. Okay. In this picture, you can see that the preamble and FFT has been given by a physical layer header, and the destination MAC address and source MAC address has been given by data link layer. Here it was all about Ethernet frames.